Welcome to today's super exciting webinar. We're going to be talking about wind farm road networks. More importantly, we are going to be officially kicking Path Explorer AI networks off into beta. So today we're going to be talking a little bit more about that new tool, how you can use it, and what that workflow looks like. If you are new to our webinars, first off, welcome. Secondly, these webinars are intended to be quite interactive. If you have questions, please do type them in that GoToWebinar chat anytime throughout the webinar, and we're happy to answer them. Sometimes there's little breaks for calculations. We can answer them there, as well as at the end. We usually designate a bit of time. With me today is my colleague, Matthew Dickey, our resident webinar software running expert. I have to say, this is probably the favorite part of at least my role here at Softree. It's creating this content, sharing it with you guys, and especially when we launch new features, really, really exciting. So let's get into today's webinar. I should first and foremost acknowledge, yes, the title is wind farm road networks, but the topic really does apply to a lot of adjacent resource industries. Obviously wind is the most prominent, that's why we're talking about it. But if you're doing a transmission line project connecting, transmission towers with access roads, or you're doing forestry operations connecting landings for your wood with road access, very similar ideas. So of course, today we're talking about wind, very wind focused, but the overall kind of core workflow below it absolutely applies to you folks as well. So here we're going to be really focused on a couple key goals. First and foremost is, figuring out how we can connect that key infrastructure with road access, turbines, as I mentioned, transmission towers, forestry landings. How do we minimize cost? How do we minimize environmental impact? Include things like minimizing stream crossings, make sure our standards are met, and how do we do this all in the most efficient manner, which brings us to our goals for today, slash the benefits of why you might want to play around with Path Explorer AI networks. And that absolutely is about planning faster. So being able to figure out landscape level, where should my roads go, and do so at incredible speed. That's what this tool is all about. It allows you to also reduce your earthwork costs, and we use our other part of Softree Optimal for that, especially, which is the reduction of cut and fill quantities, movement costs, and doing so across all the roads in the network. And then how do you quickly create deliverables, whether that is a multi-plot inside of RoadEng or exporting to another platform to continue to utilize your CAD standards. Of course, these is totally applicable to lots of different folks within that wind farm design process, of course, as well as those adjacent resource industries. But if you're a developer, being able to quickly plan cost, understand even just the feasibility of your site. And of course, if you're an engineering consultant, there's so much value add in the speed and efficiency of when design changes happen. It's all interactive. You can rerun networks. So those are kind of our goals and benefits of today. I should say our plan on a page, a little bit about what we're going to cover. This is going to be an end-to-end workflow. We are going to be focusing on a new wind farm, just showing the road access workflow inside of RoadEng. The product, this confuses everyone, me sometimes as well. It's RoadEng with Softree Optimal. That's our earthwork optimization add-on. And within that earthwork optimization add-on, that's where you get our special support exclusive feature, Path Explorer AI. So it's the RoadEng with Optimal. Path Explorer lives in that, and we are showing you today version 12. If you are a client on support, you can get 12. Just shoot me a note in the chat. We can get you hooked up to the beta program. It's a pretty quick and easy request. Okay, 5 key steps that we are going to cover in the workflow. So first off, spatial data, terrain, create our terrain model. I think it's the first step in literally every webinar we do here at Softree. So we'll talk a little bit about that. Then we're going to add additional spatial data, geometric constraints. This can include our turbine locations, if there's, exclusion areas that we can't include for the road network. Perhaps there are right-of-way constraints. We can add all that stuff in. Then we're going to use our AI-driven road network generation tool, Path Explorer AI Networks. Super exciting and quick asterisk on that, it is all locally processed on your computer. So nothing is leaving your computer and we're not learning off your data. You know, those always typically come up in the question section, so I might as well answer them now. Then from there, detailed design, mass haul optimization. Again, I mentioned there's 2 optimization steps. One's going to be Path Explorer. One's going to be that profile or mass haul optimization. And then lastly, we'll quickly touch on construction-ready deliverables. So to finally, before I pass it to Matt, visualize the problem that we're solving today. You've got a terrain, you know where you're going to put your turbines, then we're going to add some constraints to it. This could be that sensitive animal habitat, could be our water courses and our streams. It could also be like maybe we've got obviously the turbine laydown areas that we need to come in with a certain approach to, and maybe we have existing roading that we could include in our network. So using all of that visual information and spatial information, we are then going to let the software help us figure out the best way to connect those turbines. And again, it does so with those 2 key optimization tools. Path Explorer AI, that's going to figure out landscape level, where do we put the roads, how do we connect the turbines or the points, and then profile optimization, which really looks at minimizing cuts, fills, movement costs, bouncers, your earthworks, and you know, can typically 10 to 30% reduction in subgrade costs just with that step alone. Okay, that is enough for me. Matt, I'm going to turn off my camera. We're going to get into the software, ask us questions, and let's check out Path Explorer AI Networks.
There we go. And before I dive right into starting from scratch, I'll give that teaser, I guess, for conceptually what we're starting with, where we're going with the big one before we break down those little steps and look at how we got there. So this is the project that we'll be looking at today. With this, each one of these little points here represents a turbine site. Of course, we've got existing roads. So either side of this ridge, we've got an existing road. And then we've got, an area, we've got critical habitat that we don't want to go into. We've got, some residential areas that as long as we can reasonably avoid it, we don't want to go there. But if we had to, maybe we could buy land. We've got a ski area that, of course, we don't want to interfere with. And while looking at it in the plan view, it's great, but we'll look at it in the 3D as well, just to kind of digest what we have going on. So we've got, those no-go sites. If we zoom in here, we can see each one of those turbine locations. And of course, when we're faced with that big front-end problem of how do we get there, if we're going to plan the roads in any amount of detail manually, it would take quite a bit of time to figure out how we can reasonably get there, but even more time to find an optimal route to get there for again, each one of those individual points. So with Path Explorer AI, we can take those inputs, we can go up here, we can put in our design constraints, and what we end up with is something that looks like this. So the software, we gave it that start location, found the best way to come off the existing road. It's a little longer than the steep side, but we get up there and we have those routes set up where we're minimizing construction costs while adhering to all those design criteria that we'd like to. And of course, this is just Path Explorer. So this is that front end. Where should I put my road? And then we'll take it over to location and we'll get that proper geometric design for all of these routes fairly quickly. So with that little bit of a primer, I am going to close these and we're going to go back in time and start from scratch. But as Aaron said, just with a smaller example to save the calculation time. And that one that took a little under an hour, it was 50 minutes-ish. There's 34. I did check the number of turbines before I jumped into this one. So. All right, so kind of rewinding, going to square one. Well, we're going to start in the train module of the software. So in this train module, we're going to well, bring in our spatial information. So of course, the big one right off the bat is, well, we want to have our topo data brought in. So in this case, I'm just going to bring in a DEM, work with a wide variety of sources. But yeah, I'll run with DEM, and then basically the workflow for working with last data is very much the same. All right, so we're bringing in those points. Now it's a fairly large file, so I'm going to just thin my data here a bit. I'm going to do a quick simplification that's going to preserve, well, the important points to capture undulations in topography, but get rid of the ones on more planar slopes. And we're going to take all those points and we're going to turn them into a tin. So we'll come up here, we'll click generate. I'm going to not create contours just because I'm going to add in more spatial information for context. So, and I'm going to use the 3D to largely have a feel for what the ground's doing. So we're going to skip our contours, but we could generate them if we wanted to just as easily. And so I did promise that we'd have a 3D. So there's our 3D, and that's the topo that we're dealing with. Now, with this, we could, of course, just arbitrarily throw in a few points, put in a start point, put in our design criteria, and away we go. But there's inevitably more things that we'd like to consider. So I'm going to just start bringing in, well, some of the common elements that we'd like to consider. And again, we could draw them in if we didn't have them, knew where they were at. But yeah, a lot of the time this data predates starting a project, like existing roads. So if I want to come up here and I want to insert, say, another data source, well, we can grab that, bring it in, and away we go. So this is just from a shapefile. Could be a DWG, DGN, DXF, etc. So we've got those existing roads in there. Now, where do we want to go? I'm going to dump in those points that represent my turbine locations. And there are 3 of them. There'll be just a really small dot to start there. So I'm going to just make those a little easier to see. And there we are. And we can tile these side by side as we go. So there's our 3 turbines. Now, with this, well, we may want to have that extra context of just, well, is there something that we're not capturing with our vector data? Well, for that, we could bring in an image. So if we didn't have our own image already, we could go into Live Maps and download it from a variety of sources or add our own sources in. In this case, I've already have my ortho downloaded, so I'm just going to add it in here. And again, add context. Now, aside from that, there's a few things that we'd like to avoid in this, and it is a subset of that larger problem that we were just looking at. So we have that critical habitat that we'd like to avoid. So peregrine falcon nesting habitat in this case on the cliffs. So I have a shapefile for that. We'll bring it in. There we are. And I'm just going to hatch that. We'll make it red. And there we are. So we don't want to go there. Now there's also, well, those, in this case, a few areas with houses that we'd like to avoid. They're not critical in the sense that, well, if we had to go through there to make our project feasible, maybe we buy them. But we'll bring those in and we'll add those elements as a deterrent. And again, here I'm just going to change my line work a little bit so we can see what it is. Set that on the surface. Sure. So we've got those areas there that we'd like to avoid. And, well, if we were to go from somewhere along this existing road up to those turbines, well, there's probably streams and wet areas, etc., that we'd like to avoid. So rather than bringing in a data set that already exists in that case, I'm going to use the hydrology tools in here. I'm going to use the streams and ponds tool, and I'm going to say, well, let's calculate where the streams likely are. And sure. And we'll get ponding areas too when we calculate this. There we are. Now, as we go through the process here, we could run the Path Explorer AI up to these points. But of course, usually we're going to have some kind of a hard stand or lay down arrangement. And it's going to be non-trivial in size. So it may control where it makes sense to approach from. So in this case, rather than just using those endpoints, I'm going to bring in a generic pad configuration, and I'm going to move it into place. So here I've got one that's already saved. And of course, we could just mock that up, have it behave the way we'd like. But I've got my generic pad here. Well, we could just grab it. We could move it over to where we'd like. We could rotate it, position it. Now, if we were doing this, I wouldn't be as concerned about getting it bang on the right elevation, dealing with my crossfall, longitudinal grade, etc. I just want to get it in the right position horizontally. And aside from just moving it around and rotating it manually, if we wanted to, we could come up here and we could say, well, I want to move this, and I'm going to snap that point to that point, and ta-da. Now to save me moving things around 3 times over and over again, I'll just dump in a file that has the other 2 already placed in there too. So those are the features we'd like to go to. And if we zoom in here, so we're not going to go to this feature here. Instead, we're going to go to this feature here. So just the center line of our pad. And we're going to tell it that those centerline features are acting as a feature that's going to control our tangent direction as we approach them. So we're going to tag those features as tangents. And with that, I think I've got enough explanation. Things are set up. We've kind of painted the picture for what we're dealing with here. And well, we're going to set up the tool. I'm going to go to the optimization tab. I'll click Path Explorer AI, and we're going to put in a few parameters. So one, my minimum curve radius is going to be an important one. We're going to set that. I'm going to go with a minimum curve radius of 50 meters. We're going to give one network option here. My max grades, I'll set those at, well, whatever I'd like. And in this case, it is quite mountainous. I'm going to go with 14%. I'm going to set my max cuts and fills at, say, 8%. And, well, away we go. Away we go to the next page here. So this is our general. We've got our dollars per cubic meter for our cuts, dollars per cubic meter for our fill, kind of the defaults for what the software is going to consider. Now, the endpoints tab. So over here, we're going to say that this is a network problem. And if we stayed with connect and sequence, well, it would go from, say, that existing road to that pad and connect it all on a single road, which we don't really want. We'd end up paying more than what we want to for building this thing. So we're going to select that it's a network problem. We've got our existing road, and then we're going to add in those other 3 features. Now our existing road, of course, is the start of our new road. So we want that at the top. The order of these other 3 or other 34, however many you're doing, doesn't matter other than, well, you want the start at the start. And then that existing road, we're going to tell it that it is an existing road. when we do that, the software kind of sees as being able to leave this road anywhere and kind of go along that road without having to pay to rebuild something. It's also going to adhere to kind of direction constraints as we deviate from it. And then those tangent features or centerline features, we tag those in as being tangents. And then lastly, well, we've taken the time to bring in that extra spatial information that we'd like to consider that deviates from our defaults. So we'll set that up in our construction zones. So in here, we're going to click this guy. So right off the bat, that nesting habitat, well, we don't want to go in there no matter what. It's not that it's going to be expensive if we deal with it. It's going to be so cumbersome that it'll sink the project. So we're going to just make that an absolute no-go. So that is, can't go there at all. Now, I'll choose which features I'd like to use, and in this case, I only have one. So that's populated, we can't go there. Then we can come down here and we can say, well, those residential areas, if we had to go there, we could, but they're going to be more expensive. So we can say, well, let's just make it a polygon. And well, we can come down here, and there's only 2 in this case. And we can say, well, a lot of these elements are going to stay the same, but I'm going to increase my surface cost for this thing. So let's go with, I don't know, $100 a square meter. Well, then we can keep adding in a little bit more. So the next big one, well, is our polylines. And so these polylines are going to be those streams. And well, here we're going to say any of those stream features are going to cost $5,000 to cross. The rest of this, again, our design parameters are going to stay the same, and away we go. So, and yeah, just a little bit of a sidebar. So we've got no-go polygons, no-go polylines where I can't cross this feature, or polygons I can't go into this feature. So polygons that aren't no-goes, we can add an extra cost. Polylines, add an extra crossing cost in there, change our design criteria to cross it, etc. Existing roads. So if we had an existing road that wasn't an endpoint, we could still treat it as kind of a free move along it. We don't have to visit it, but if it makes our solution cheaper, we can. And then tangents would be, well, another case, maybe we have something that is a potential bridge across the river. We don't want to cross the river elsewhere. Well, we could use an optional tangent to kind of limit where it crosses. So we've got things set up. We'll hit OK. It's going to think for a bit. And we probably have, I don't know, 2 minutes here while it chugs away and determines the best route to get up to where we'd like to go.
Perfect time for a question, Matt. So we've
All right.
got one here in the chat. Is there a recommended system requirement to ensure timely processing? Not a minimum requirement, but a recommended.
Okay. Yeah, the more computing power, the higher the ceiling is. So yeah, I guess for context, I have an i7 processor with 16 gigs of RAM, and I'm quite comfortable zooming around and running the software with that. But if you had really, really large projects, RAM is a hot commodity. So yeah, RAM goes further with the things, and then, well, CPU, more compute power, the faster things will go, more threads, etc. So yeah, it's with that, I don't really have an exact recommended. I think it really depends on how large the projects are you're doing. Yeah, and
we're
especially
happy, I was going to say, for that question asker, we're happy to, if you want to give us some specs on what kind of project scale you're dealing with, we're happy to make a recommendation. Because yeah, again, it's very much tied to size of terrain, complexity of terrain, and obviously complexity of the path exploration you're doing. Those are two largest memory consuming processes. I'm sorry, Matt, I felt like I cut you off.
No, not at all. It's yeah, it's just kind of one of those things that we've got, well, minimum recommended, but yeah, if you're doing really large projects, but sometimes these wind projects can get quite large in scale, in which case, yeah, something that's appropriate for the particular project. And that being said here too, it's done. It's well, it's thought about what we've given it. And we can see here, well, we've got a line and going up the hill. So we're dealing with 6.3 kilometers for kind of the longest route. And then we have, well, this guy coming off and that guy coming off of it as well. So pretty quick for what it's doing. And yeah, of course, it kind of spoiled the surprise looking at the other example. But yeah, on that other one, when I first set it up, I had no idea which side of the hill to come up. And yeah, being a little lazy, I didn't have to give it much thought either. I let the computer figure it out. So we've got this though. I'm going to hit save. So that was Path Explorer. That's the work that we did in the terrain module. I'm going to just save this as topo. And then we're going to, I'll jump over to location. We're going to take this really smart line on the map. And when we say line on the map, it is kind of underselling it. It is a 3D solve that's using a cross section. And well, if it makes sense to go through something, it will. If it makes sense to go around it, it will. But the solution that it gives is this line. So we're going to take that and turn it into a geometric design. So we're going to go over to the location module. And we're going to come up here. We're going to click new. And we're going to reference that terrain file that we just saved. And I think I saved it in here. Yep. So we're referencing that terrain file. And well, next we're going to say, well, I want to bring in those Path Explorer solutions as kind of my initial. All right, so I'll zoom out here. Now with this, there's a few things that we'll typically do just to, well, get things set up and looking the way we'd like. So we took the time to get that ortho image. We probably want that in the background here as well. We can go plan options, click the little plus next to our background tab, grab that image. We'll shift that guy up, we'll hit OK. And we'll hit OK. Now, oops. Then we can take all the solution that we're looking at here, and we're going to further refine it. So right off the bat, if we just zoom in here, we will see that we have an actual 3D model appearing now for where our road's going to be. But we may also notice that there's some things that we'd probably like to refine. So that really smart line on the map that Path Explorer produces, it is a polyline. So it is considering our curvature, but it's producing, well, a line that is a series of chords. So to get around that, we're going to come over here. We're going to click Operations. We're going to click Polyline to Alignment, and we're going to say, well, let's fit those minimum radius curves of 50. We'll give it a little bit of a tolerance to allow it to, well, straighten out any slight jogs that there may be in the geometry. And we'll let this thing go. And it's going to chug away. The longer we let it go, the fewer IPs it's, and the closer it'll match that original solution. But the output is going to be, well, a series of curves and tangents. So we can let it go. Now I'm going to be lazy here. I'm going to hit cancel. And there we are. So we've got our proper curves fit to this, and well, all the way out to the end. Next, we're going to set up our cross section here. So our cross section is, actually, I'm just going to move this over here so we're at the end of our road here. So this cross section is controlled by our cross section templates. So I've got a little library here. I can assign different cross sections to different portions of our road if we like. Now, when we install the software, there's going to be 3 that come by default. This other one is added in, so it's basically just this low volume road. So we can see the parts of it. Well, we've got that low volume road, but we've got a pad component in here. So that component, we've got a bunch of components available on the eLibrary here. That pad component lives in here. So it was just a matter of copying it, pasting it in, and saving it. So I didn't have to do that this time. But the thing that is nice about this is we can double click it and we can say, well, instead of having to tabularly assign where the pad edge is going to be, we can just use an offset that ties to those edge features. So I'm going to set that up. So we'll say that the feature comes from our topo train file, and I'm just going to grab all the pad limit features here, and there we are. So we'll hit OK, we'll hit OK, and we'll hit OK. So now we can see, well, that pad is taking shape. The next thing we're going to do before we optimize this vertically is we're going to account for the fact that most of this road is screaming up the hill at up to 14%. But once we get into this hard stand, we don't want to have a longitudinal grade of 14%. So I'm going to tell it from station 6050 onward, we want to I'll keep it to less than 4%. So I'm just taking a note of what that station is. Now, for my own sanity, I'm going to call this longer road our main road. So just changing the name. I'm going to shift it up to the top. So just keeping track of it's being done first. And then we'll dive in and we'll set up those vertical optimization parameters. So in here, we've got those max min grades. We've got our K values set. Here again, so from station 60, 50 to the end of my road, I want to have no vertical curves. I want to have those reduced grades. There we are. Now we can also have it so it's going to fix the elevation at specific points if we have to. So here I'm using control points. The only control point I'm going to use in this one is the start of the road. And then, we're going to keep this fairly superficial, but and it wouldn't need it anyway here, but we could add in pits and spoil sites if we didn't think it was going to balance, or if we had unsuitable material that we wanted to account for spoiling. For this, I'm just using a single ground type. Now, with that, we've got our little bit of a library here, and again, we can add our own materials to that. But here we can have different materials that cost different unit rates to excavate. So my overburden is going to be $12 a cubic meter, whereas if I'm drilling and blasting the whole way, well, maybe that's $48 a cubic meter. So if we had decent geotechnical information, we could add in all those different subhorizons, stripping areas, the quality of material, shrink swell, etc. And as the software does this, whether we have one material or multiple materials, it's going to look at, well, balancing those materials, and as it balances, minimizing our longitudinal movement and the costs associated with that. So we've got different unit rates for, well, pre-haul, overhaul, end haul, moving that material different distances. And then constraints, again, we can add in more detail. If it was, say, overlanding across a swamp, well, we could add in a minimum embankment height. If we were traversing an 80% slope across a mountain, we could add a full bench constraint. If we wanted to control the way mass haul was moved, well, we could control the movement direction. But again, particularly, well, easier projects or preliminary projects will generally leave that out. But yeah, you can certainly go as deep as you want, and the software is quite smart on that stuff too. And from here, we'll hit process, and we'll let this thing think again. And it's going to chug away. And we'll get an optimized vertical alignment here shortly.
Okay, shall we answer a couple of questions while this is chugging along? I have to say, engaged audience, I think I've answered like 20 questions by text already. Oh goodness, it's not going to give me enough time by the time I pick one. Quick question, this one should be easy. Can you use shapefiles or points for the wind turbine locations instead of manually inserting them?
Yep. So the example that we had here, those WTG, that WTG file that I brought in was from a shapefile. So yes, shapefile, absolutely, and we did it in this case. But other common formats, you may have them in, say, a DWG, DXF, DGN, KML, even. Yeah, kind of all the common vector formats. We have that covered. So you don't have to draw them in or anything like that. You can work with the data that you already have. Now, this did run. So as Aaron said, it was pretty quick. So what we end up with this, and I'll just zoom out here, which of course will lose the scale of things. But yeah, we've got this road that's climbing up, and if we zoom in anywhere along here, we can see we're staying within the 14% max grade that we've spec'd. But I guess the more impressive thing, if we look at this, is the mass haul. So we've got relatively small movements for the type of terrain that we're dealing with here. Obviously, we've got a few larger ones. Well, we've got a decent sized crossing at the front with a through cut heading into it. And then the other bigger ones are, well, our pad at the end, etc. So it's, well, we're perfectly balanced. And well, then if we kind of focus on just the end there, well, we told it to keep that within 4%. So our pad at the end, now we do have a crossfall, so we don't have to worry about any water standing, but longitudinally, we've got that at a 0% grade. And yeah, just moving that material from basically the midpoint up ahead, where we're filling more off that edge, and then back. So it's very smart. It's not moving material any further than it has to. So we've got one of our alignments done here. Now we're going to take it a little further here. I'm going to just, and for the sake of time, I'll nuke this one. It's going to be the same process for the next one anyway. So if we want to continue that process, well, we certainly can. So this other one, I'll just, again, for my own sanity, we'll call it sec for secondary. And well, with this, we can see when we use that polyline to alignment tool and gave it a tolerance, well, our solution's a little off where it was originally. So we can just grab this guy, pull it over there. So we're snapped onto that center line. And well, we can run polyline to alignment on this new alignment that we have here. So same concept. We're just going to simplify that down into a series of curves and tangents, kind of the line of best fit. And I'll be impatient here, and we'll tell it to stop before it wants to. And well, if we want to, now this road that we've already designed, we've got that elevation more or less set. So when I'll do my optimization, I want this to be at that same elevation, etc. At that particular point, we're going to use the merge surface from that. So if I want this to act as though that road was built when this one was here, well, we can come up here and we can say, well, that main road is merged into our topo. And well, once again, over here, we're going to say, well, we want to know the station where we want to have that pad go flat. And then we're also going to set up the reference features for this alignment, so it goes out to that pad edge that we'd like to use. So we'll come in here, grab those features from our topo. There they are. There they are. And we're going to come over here, do those vertical specs that we do. We're going to add that in and save from 890 onward. And for this, of course, last time I was just giving context for all these other tabs, but yeah, I don't think we need any more than just that for this one to get an optimal solution. So we'll hit OK. We'll let this guy run here. And voila. So once again, we can see we've got a solution. The mass all looks really, really good at a glance. We can come over here. We can look at our volumes. So this is my volumes broken down in 250 meter increments. So this one we're looking at, what is that, 21,000. This other one, we'll do a quick recost. And we'll scroll right down to the end. So we're at 45,000. If we wanted to have another data table that just summarized each one of those kind of by alignment, well, we could do that. So I want to see my cuts, fills. I've got surfacing material in there as well, so we can see those, our volumes. And then if we want to progress through, and well, we could, of course, add in our culverts. Now I'm going to skip the culverts, pretty straightforward to just drop them in. And then we'll go over to our documentation. So we've got our kind of paper space equivalent, which is the multi-plot. And well, for this guy here, we could build out a document entirely from scratch. I'm not going to do that in this case. I'm going to bring in one that I've already saved. So we've got a book. So in that book, we have chapters. So we're looking at just my title block here to start. Then I've got my plan over profile. In this case, we're looking at just our secondary road. And we probably want to have another one of these chapters. So this is going to be fixed to my secondary road. And I'm going to duplicate it. This one's going to be my main road. There we are. So we can see we're following along the alignment. And we could do the same for our sections as well. So here we can see right off the start, now we're looking at just the secondary here, but we're on the existing road. We deviate, come along, and voila. So pretty quick to get to the documentation side of things. Yeah, and of course, we're kind of just starting from scratch. In many cases, we might not know those geotechnical elements, so we could take this out to the field for the field investigation, collect more information, come back, and then we could add in subsurface information, etc., and further refine it before we put it out to tendering or construction. So with that, oh, and yeah, I guess the last thing here, just circling back to it, is, well, what does that big one look like when it's all put together?
A good reminder point, if you're a moment late joining the webinar, we are actually running the beta version of our software. It is due out imminently within, I'd say, the next couple months. It's out in beta testing. Clients on supports absolutely can get access to what Matt has right here today.
I can answer a couple questions here. Well,
perfect. We'll pick an easy one. This question is, as most of what we do is in the planning stage, we don't require the 3D until a later stage. Can you export the paths as a shapefile?
Yep, you totally can. So here we can just highlight over top of it, file, save as, change the format to whatever we like, and give it a name. Now, with this, of course, I only want those selected features, not everything. So we'll toggle that on, and then we've got our selected feature will be exported out as a polygon, and away we go. And I won't hit OK just because I don't have use for it, but yeah, there we are. And there's our big example here, all flashed up with the full solution, everything modeled, and away we go. So multi-plot, very similar, and it's just loading the images in there. So basically what we looked at before, and this one is a larger project, so more dirt, more spurs, etc. Yeah, we can have a peek at that. So data options, and well, we could do our alignment summary again if we wanted to look at each one of those one by one. If we wanted to do something different, I hit cancel there too. We could customize what we want to see. So change the elements. We could look at total number of pipes. Again, I haven't added those in. We could have our staking information, how much dirt for individual layers that we're encountering, etc. So pretty slick, pretty easy to work with, and yeah, that's kind of does a little more justice when we look at it for the 3D for what those lines actually represent on the ground. We can see no crazy cuts or fills. It's working with the topography that's there. Yeah, and with that, I guess probably answer a few questions.
Let's do it. Okay, so many. I'm trying to pick the ones that are relatively quick because I see that we are very quickly approaching over time. There are two questions, Matt, really similar in the same kind of space, basically asking about materials, material handling, layer thickness, if you can get estimates by material type. And I'm just going to grab the other one that's very similar to that and read it out as well. Geotechnical parameters, peat, soil, rock layers to reflect different cut and fill rules and rates for soil properties. Which I feel like this is your favorite part of the software.
This is my favorite part. Yeah,
deep into the swimming pool, and I just want to remind you, we have tight time left.
I will broad brush it rather than give the verbose answer. No matter what you're dealing with there, whether you want to go superficial and just keep it simple, or if you wanted to dive in with more information, you absolutely can. So we have ground types, so we can have a collection of different materials that we can assign along the length of our road. Now, each material, we can have different properties for cut slope, fill slope, angle, if we want that to be set based off the material, or we could use just a fixed slope. And then we've got our expansion factors. So as we're balancing it, where we're not just kind of broad brushing and it's all the same. Well, if you have rock, it's going to expand. If you have, say, a loose material, a loose fine grain material, it's going to shrink. Well, we can account for all of that in here. So these materials that we want to account for, we can go assign by range, we can go sub-horizons, and we can add in, well, what horizon belongs to what. If we have really good data and have our own independent subsurface, we could reference that. If we don't, well, we're not stuck either. We could just use a kind of a tabular offset from the topo. So I could say I've got a meter of hard pan over solid rock, and I could say that belongs from station X to station Y. So yeah, we can track all those different kind of geological units and how much we're cutting and filling and balancing with those for specific zones. And then of course, stripping is going to be accounted for as part of the site prep process. So we can say, well, how much material that we'd like to just remove and assume that that's not suitable for anything. So we could add that in there. yeah, and then we could go even deeper with it. I've got rock here. I need to use the rock for a riprap slope or something like that, and the software will actually balance everything out and account for that, well, extra haulage with it. So short of clicking through all that, because yeah, as Aaron said, I have a knack for talking about that stuff more than I probably should, and we're already over time. But yeah, we have lots of resources for, well, video content, articles, etc. on that. But if there's anything that you'd like to discuss in more detail, let us know, and we can certainly jump on a call and hash it out.
2 minutes on the question, Matt. I'm impressed. Well done. Okay, let's tackle maybe one or two more. This is a great question. Can you fix the elevation of a pad as well? Because sometimes you want the turbine foundation to be at a very specific elevation.
Yep. So in here, one, if we wanted the whole pad to say be flat, well, we could just linear 0, 0, or +2, +2 if we wanted to just keep it on a specific grade. But control points will let you set it at a specific elevation. So you can say at station X, I want to be at this elevation. And yeah, we'll say, I don't know, station 1050, I want to be at elevation 589. And then that point is going to be absolutely fixed where it won't go up or down. And you could go a little further with it where you could say, well, I only want to allow it to move up, and then it'll only move up. So you can set those tolerances in there too. Yep, pretty straightforward to deal with.
Okay, let's do one more question, because I really like this one as well. If we have our own hard stand shapefile, does the software allow us to import that as well? Will it assume earthworks based on our hard stand shapefile? I was hoping to do all the wind turbines and hard stand placements in QGIS and then let the software do the road alignments.
Yep.
Really great question.
Yep, and that'd be basically the same process where I grabbed that placed pads file. Mine was a train file, but it could have just as easily been a shape file, or DWG, DGN, etc. Just yeah, any common spatial format, you should be able to ingest it, and you're set. So no issues there.
Awesome. Okay, let's do one more. And this one looks like an existing user based on the question. So for context, Path Explorer AI came up with an A to B function, and this question looks like it ties directly into that. It says, so the tangent doesn't need a direction anymore. Will the network be able to approach from either way?
So currently the tangent is directional. So yeah, with the direction, the vector is directional. Now, same with the existing roads. So if you have an existing road, that is directional as well. And yeah, I'll just kind of come back to this guy here. So with that, now it's just showing as a line. But I'll show it as a series of arrows here. So we've got that guy going there. Now, if we wanted to have this road act as though we're a bidirectional road, so allowed to go in either direction, we could just copy it, paste, and reverse. So modify, reverse, and then we could have two features on top of each other that account for the bidirectionality of it. But that bidirectionality is more for the existing roads than tangents. Tangents will generally be just directional.
And with that,
answers the question.
there's a handful of questions still left in the chat here. I've done my best to answer them directly over text. But if anyone has any additional questions following this seminar, we are absolutely happy to answer them. You will be receiving an email. For those of you here in the live version of this webinar, you're going to be getting an email with a follow-up certificate, as well as a link to the video. you're welcome to reply to that, and we'll make sure someone on our support team tackles any other questions. And we hope to see you all at a future webinar. I know most of our webinars are done at 11 a.m. Pacific time, which for those of you in the Southern Hemisphere, especially Australia, New Zealand, tend to be at a pretty awful hour in the morning. So for that, we're sorry. We are trying our best to add in some sporadically to fit with your time zone. Okay, everybody. So we're going to wrap it up there. To the last remaining couple of questions, we'll follow up with you guys separately. But I just wanted to thank everyone for attending today. We are, super jazzed to have Path Explorer AI Networks out now in beta. Clients can get access. Shoot us a note if you'd like to join the test. And beyond that, we'll see you all at another upcoming webinar soon. Thanks, everybody.
Thanks, everyone.